So good afternoon all. In the previous lecture, we have discussed the cases of the earth pressure in the cohesive soil. So what is the difference between the cohesive soil and cohesionless soil when it is being used as a backfill material, right? So when there is a sandy soil or the cohesionless soil, the pressure is acting immediately from the top and it will be increases with the depth, right? But when the backfill soil is a clayey soil, so clayey soil is the soil which can be stand unsupported up to certain depth. Means it can be stand without any support, and therefore it means that the pressure is not acting immediately over the wall. There is after certain depth the pressure is at, and that depth is called as the uh, depth of potential crack, up to which there is no pressure. The soil is self-stabilized. It will not exerting any pressure over the wall. After certain depth, means after the depth of ZC, it will be exerting the pressure, and HC is the height of the critical depth at which, or that is the minimum depth of excavation without any support. So here we will just consider, this is the retaining, all these things we have already discussed in the previous lecture. So H is the retaining wall, retains cohesive backfill, that is called as clayey soil, having the properties of C, which is in kilonewton per meter square, pi is 0 and gamma is kilonewton per meter. So here we are assuming that the pressure is negative positive because cohesive soils are stand unsupported without any support. उसको support लगाने की जरूरत नहीं रहती है कुछ depth तक, और वो depth जो रहती है that is HC, and that will be, so there is no pressure on the wall, or in fact we can say there is a negative pressure on the wall, and the intensity of it is minus 2c cot alpha. It will be minus 2c cot alpha. What is alpha? Alpha is equal to 45 plus 5 and 2. Now, if the soil is pure clay, if soil is pure clay, the value of phi will be 0, phi is equal to 0, and therefore alpha is equal to 45. So alpha is equal to 45, right? So in this case, this is the minus 2c cot alpha, and over here it will be gamma into h cot square alpha minus 2c cot of alpha. So this is the bottom value. Now here, as we know, the distribution diagram is a positive negative distribution diagram. Here there is a negative pressure, here there is a positive pressure, right? So what is this depth? This depth is called as ZC. So ZC is the depth after which the pressure is acting over the wall. Means the pressure is acting from this length. This will be the length of the wall at which there is no pressure, right? So यहाँ तक कि ये pressure आ गया है, but which depth is considered as unsupported depth of excavation? This is called as unsupported depth of excavation. Unsupported depth of excavation, and that is called as HC. So this HC is equal to twice ZC. This is twice ZC. Means suppose the depth of potential crack is 1 meter, so in that case the soil can be stabilized up to a depth of 2 meter when we made the excavation into such a soils. After 2 meter depth, we have to provide a lateral support in the form of shipping and dressing, right? So in this case, how the pressure is being calculated? Which pressure is acting over the wall? That pressure acting over the wall is the area of the positive pressure distribution diagram. Area of positive pressure distribution diagram, which is acting at TA, and this will be acting at the distance h minus ZC divided by 3. Then what is PA? PA is, or first we will discuss what is ZC. ZC is 2c upon gamma into tan of alpha, where ZC is the depth ZC is the depth at which PA is equal to 0. PA is equal to 0. Then what is HC? HC is equal to 2 times ZC. Means here this HC can be calculated as 4C upon gamma into tan of alpha. Right? And then what is PA? PA is area of positive diagram. And that will be half of gamma into H cot square alpha minus 2C cot of alpha into H minus Z. So where it will be at? It will be at distance Z bar, which is H minus ZC by 3 from bottom. So this is the somewhat different assumptions are there in the cohesion. Now we will discuss the numerical based on it, right? So first, I just write the given data over the blackboard. So here, in an open excavation, is carried out in a soil of properties phi is equal to 10 degree, then gamma is given as 80 kilonewton per meter cube. You have to find out the value of C. You have to find out the value of C, but in this case, the critical height of cut is given. Critical height of cut is equal to. So what is the critical height of cut is? It is HC is given as HC is given as 3 meter and the height of the wall is given as H is given as 8 meters. So the height of the wall is given as 8 meter. The soil or the backfield behind the retaining wall is a C5 style where phi is 10 degrees. C have to calculate and gamma is 18 kilonewton per meter. So in this numerical, the HC value is given. That is the unsupported length of the excavation or it is the critical height of the cut. Means HC is given. So what is the backfield? So here we will just consider this H is the height of the retaining wall, which is given as 8 meter, and here you can say the height is given as this is ZC and this is also ZC. So the HC is given as 3 meters. So this much data is given. HC is given as 3 meters. So no doubt ZC will be 1.5. And what is the bottom? At the top it will be minus 2C cot of alpha. At the bottom it will be gamma into H cot square alpha minus 2C cot of alpha. Right? So this is the data which is given. In this case now, the value of HC is given and you have to find out the value of phi is given as 10 degree, then gamma is given as 18 and you have to find out the value of C. Now you are having the equation for HC. What is the equation of HC? HC is equal to 4C upon gamma into tan of alpha. So this is the equation by which we can find out the value of C. So what is alpha? Alpha is equal to 45 plus 5 by 2. So what is the value of phi? The value of phi is given as 10 degree. So it will be alpha is equal to 50. Alpha is equal to 50. Now we just put the values of this HC into the equation. So HC is given as 3 meters. 3 meter into gamma is 18 divided by 4, which is equal to C into tan. C into tan of 50. So from these given data, we can obtain the value of C. So what is C? C is found to be 11.33. 11.33 kilonewton per meter square. So this is the value for C is obtained. Once you get the value of C, you can calculate this value, you can calculate this value, and you can calculate the area of the diagram. But in this numerical, you have to find out the area of the positive distribution diagram. Here it will be a positive one, and this is found to be 82.37, and it is minus 90. So just calculate the area. What is this there then? This is 1.5 meters. So this depth is 6.5 meter. So it will be 6.5 meter. Right? So in this case, the PA is equal to half of 82.37 multiplied by 6.5, and CA is found to be 267.7 kilonewton per meter round. And this PA is acting at 6.5 by 3 distance from bottom. And so it is found to be 2.17 meters. So this is the simple numerical that we have discussed. So in this case, the ZC is given. The HC is given. From this HC, you find out the value of ZC, because HC by 2 will give you the ZC. Then put the values, all the values into the equation of HC. HC is equal to 4C upon gamma into tan alpha. Once you get the value of C, then put it over here, get the bottom coordinate, and just calculate the area of positive distribution diagram to calculate the active or pressure. Right? Now we'll discuss the second numerical. So in this case, the retaining wall 8 meter high retains cohesive backfill. Now here, the data which is given data, retaining wall of height RE wall of H is equal to 8 meters. Then phi is given as backfill property. Where phi is given as 25 degree. Then gamma is 18 kilonewton per meter cube. C is equal to 15 kilonewton per meter square. And here the surcharge load is given. Surcharge above or at the backfill. That is, Q is given as 60 kilonewton per meter square, which is placed over the ground level or the horizontal surface of the wall. So in this problem, what is the difference in this and the previous one? Here, with the backfill, there is a surcharge loading is given, right? With the backfill, the surcharge loading is given. So here, this is the retaining wall of H is equal to 8 meters, right? Then the soil is a C5 soil and there is a surcharge. This surcharge is of 60 kilonewton per meter square. Now, as we have discussed previously also, there is a distribution diagram due to the surcharge load. This surcharge is a throughout acting same. So this surcharge will be same over here, it will be same over here, it will be same over here. It will be same throughout the depth of the wall. Therefore, the distribution diagram in this case is a rectangular distribution diagram due to the surcharge. So here, first diagram, what is C? C is given as 15, gamma is given as 18, phi is given as 25. So this much is the data given. And addition to that, there is a surcharge. So first distribution diagram is due to surcharge is a rectangular one. In this case, now you have to find out the value of Ka. It will be 1 minus sine 25 divided by 1 plus sine 25. So you have to first find out the value of Ka because this Ka will be required over here. So Ka value is found to be 0.4. Ka value is found to be 0.4. And here, what is this? Intensity is Q into Ka. This is Q into Ka. What is Q into Ka? Ka is 0.4 and Q is 60. So it will be 24 at the bottom or at the top. It will be a rectangular diagram. So here this intensity is 24. Right? Then there is a negative positive pressure distribution diagram due to the backfill soil. As the soil is a clay soil or C5 soil, the distribution is negative positive. So here I just draw the diagram. This is this is gamma into H cot square alpha minus 2C cot of alpha. So this is the thing. Then it is minus 2C cot of alpha. This is minus 2C cot of alpha. So it is found to be 5.24. It is found to be 5.24 and the sign is negative, right? And at the bottom it will be 63.68. Sorry, this is 24 over here and this is 19.11. This is 19.11 and at the bottom it is 38.3. 38.3. So this is the value which is obtained by gamma into H. What's square alpha? What is alpha? Alpha is 45 plus what is phi? Phi is 25. So it will be 25 by 2 and it is found to be 57.5 degrees. Right? So in this case, we just add these two diagrams. Instead of taking the area of individual area of both, we will just add it. We will just add both the diagrams and then we will decide or calculate the area of the total distribution diagram. Here we are not taking consideration the separate diagrams. We will just take into consideration the total diagram. So this is negative, this is positive. Means the Value is positive because 24 is positive, minus 19 is 19.11 is negative. So 24 minus 19.11, it is found to be 5.24. It is found to be 5.24. This is positive. This is positive. Then again we'll add this 24 plus 38.33. So it will be 58.3. It will be 50. It will be 63.68. 63.38. This is the positive. And now we will consider the area of the positive distribution diagram. So this is total diagram. And this total diagram, here we are calculating the PA is the area of this total distribution diagram. Right? We will just calculate the area of this total distribution diagram. We can again take these is one is rectangular and another is triangle, or directly you just calculate BD plus ZD square. Right? So in this case, what is PA then? We will just consider the area of PA is A1 plus A2. That is the area of the rectangle plus area of triangle. So here it will be PA is equal to, first it will be 5.24 into 8 plus half of, what is base? Base is 63.38 minus 5.24. Whatever is the value, 63.38 minus 5.24 into height of the triangle is 8 meters. So here this PA is found to be 275.68 kilonewton per meter square per meter run. So this is the total PA. That is the area of the positive pressure distribution diagram. Now in this case, we will not take into consideration these two diagrams. First, we will calculate the individual diagrams for the pressure. First is for the this pressure, this distribution diagram is for the surcharge load. Then this pressure distribution diagram is for the backfill soil. Then we will just combine both the diagrams. We'll just combine both the diagrams, and whatever the combined diagram will obtain, where we will calculate the area of the combined diagram, and that will be the total active earth pressure. Many times it may be happen that if suppose this value is less as compared to this, in that case the total diagram will be again negative positive diagram, right? So in the same numerical, we do one thing. We will just take, see, in the same numerical, we will take this surcharge is 30 now. As it will be a 30, then the total distribution diagram will be negative positive. So here we will just consider this distribution diagram is 30 kilonewton per meter run. So what will be the change in the above diagram? Here instead of 24, the value is obtained to be 12. Instead of 24, the value is now obtained to be 12, because your 30 kilonewton is the surcharge, right? Then this will be same, and now this positive is less than the negative. Therefore, the total pressure distribution diagram is a negative positive pressure distribution diagram. So here, this is again the negative one, and in this case the total distribution diagram is again a negative positive distribution diagram. So here this is now minus 6.96 or 97, and at the bottom it will be 51.48. 51.4. Now again in this case also, whatever is the area of the positive distribution diagram that we will consider for calculating the active work pressure. And here we will just consider these distribution diagram. We will just consider these distribution diagram. Now in this case, how this distance will be calculated? This distance will be considered as h, and this is never being ZC. ZC is come in picture over here only. ZC is over here. But in the total diagram, it will never be the ZC. This may not be ZC. This is not ZC. This H we have to calculate by similarity of triangle. Right? So here H is to be calculated by similarity of triangle. Similarity of triangle, and here we will get the distance is 2.67. This distance is found to be 2.67. So this HC is 2.67. If suppose not it is around 0.96, means it is around 1. It is around 1. So if the h is 1, so in that case, what is this distance? 8 minus 1, it will be 7 meter. It will be 7 meter, and therefore PA is equal to half of 51.48 multiplied by 7. So this is found to be 181.45 kilonewton per meter run, and it will be acting at a distance. This is total PA acting at 7/3 distance from the bottom, and it will be found to be Z is 2.34 meters. Right? So by this way, whatever is the total distribution diagram, that total we have to take into consideration. If the total distribution diagram is a trapezoidal diagram, then we will take the complete trapezoidal. If the total distribution diagram is negative positive, in that case we will take a positive diagram only, and this distance we will calculate by the similarity of triangle. Right? This distance will never be in the ZC. ZC we will come or consider over here. Right? So this is the second type of problem in this. Now we will take one more problem where there is a layered soil and Now in this case, we will consider a retaining wall of 7 meter height. Just a retaining wall (7 meter). H is equal to 7 meters. Then there is a layered backfill. We will just assume this as a layered backfill. There are two layers. The first layer is of 4 meter. Total height is 7 meter. Total height of the retaining wall is 7 meter. Then there is a first layer which is of 4 meter. So H1 is 4 meters. H2 is 3 meters. C is equal to 5. Phi is equal to 30. Gamma is equal to 18. So this is C1, Phi1 and Gamma 1. As there are two layers in the backfill, so first layer is of 4 meter having cohesion is 5 kilonewton per meter square, Phi is 30 and Gamma is 18. In the second layer, C is 10, then phi is 20, and gamma is also 20. So this is the second layer. Now we will consider there are two layers. So first layer and this is the second layer, right? So in the first layer, the soil is a cohesion soil. Therefore, the distribution diagram is a negative positive distribution diagram. So before that, we have to find out the value of Ka. So what is Ka in this case? Ka, that is 1 minus sin phi upon 1 plus sin phi. It is 30 degrees, so it will be 0.33 Ka1, and Ka2 is 0.49. Then alpha again we will find out. Alpha 1 is 45 plus phi is 30, so it will be 30 by 2. So alpha 1 is equal to 60 and alpha 2 is 45 plus 20 by 2 means it is 55. So these are the values of the K and alpha, right? So in this case, this is the simple case of the cohesion is backfield. Here the diagram is a negative positive diagram. So this is the diagram. This is the diagram. Here it is minus 2c cot of alpha. It will be over here gamma into h1, gamma 1 h1 c1 alpha 1, right? So all the parameters which are related to the first layer will be taken into consideration. So here it will be gamma 1 into h1 cot square alpha 1 plus minus 2c2 cot of alpha 2. So this is the bottom. Then this is the first case. In this case, we will just consider this as ZC. So it will be ZC is equal to 2c upon gamma into tan of alpha. So this is just whatever the value we will obtain, just consider that ZC in this case is found to be 0.96. So in this case, this is found to be 0.96. So 4 minus 0.96 will become 3.04. So this depth is found to be 3.04. Right? Then this is found to be minus 5.77. And at the bottom it is 18.23. It is 18.23. So with this, what is the distribution diagram for the first one? What is the operation for the first layer? It will be the first diagram at which the base is 18.23 and the height of the triangle is 3.04. This is the area of the positive pressure distribution diagram, and this we will consider as diagram number 1. Then just consider the second layer. Now in the second layer, over this portion of the wall, the sulfate of the first layer will be act as a uniformly distributed surcharge load which will be placed at the interface of the first and second layer. Means it is placed at the above the top of the second layer. So in this case, these will be considered as surcharge. So these surcharge will be throughout in this case, and the intensity is Q, which is equal to gamma 1 into H1. So this Q is gamma 1 into H1. And what is this? Gamma is 18 and H1 is 4 meter. So it will be a 72 kilonewton. So I'll just consider this diagram. So here the surcharge pressure. This is the surcharge due to the first layer, and that is equal to Q is equal to gamma 1 into H1. So it is found to be 72. And therefore, what is the intensity over here? It will be Q into Ka2, Q into Ka2. Then there is another pressure, that is the pressure due to the soil which is placed behind the retaining wall, and that distribution diagram is a negative positive distribution diagram. So here again we will just calculate this distance. Here it is minus 2c cot of alpha. Here it will be gamma into h. Now in this case 2c2 and alpha 2 is taken into consideration because we are considering this for the bottom layer. So it will be gamma 2 into h2 into cot square alpha minus 2c cot of alpha 2. So in this case this is the pressure. Now again these are the two diagrams where we will combine these two diagrams, and the combined diagram we will consider to calculate the earth pressure for the second layer, right? So in this case, this is found to be 35.28, 35.28. Then this minus 2c is 14.02. And at the bottom it is 15.41. At the bottom it will be 15.41. Now we will again draw a combine for both. So it will be 35.28 minus 14. Means the total one is a positive. This is the total diagram. This is the total diagram. So this total diagram is having intensity 21.31, which is positive at the top, and at the bottom it will be 50.7. It will be 50.7. Again, this is the total diagram which we will take into consideration. This is the total diagram which we will take into consideration. Again, this total diagram we will just divide it into a rectangular and triangular portion, or you can calculate directly the area of trapezoid. Right? So in this case, this is the first distribution diagram, then there will be a second rectangular, and then there will be a third triangular distribution diagram that we will consider. Right? So what is total PA again? PA is A1 is the area of this distribution diagram. So here this is half of 18.23 into 3.04. This is first. Then plus area of the second distribution diagram, it will be 21.31 into 3 meter plus half of this, or half of the basic height. So it will be half of 50.7 minus 21.31 into 3 meters. So this total PA is considered as it is 163 something. It is 163 kilonewton per meter round. Right? So this is the total PA. Now the combined, where this combined PA will be at a distance. Again we will consider this distance is A1. Here it will be Z1. So how do we get the value of Z1? Z1 is H2 plus H1 by, or H1 by 3, it will be 3.04 by 3. 3.04 by 3. Then Z2 is equal to, this is 3 meters, and the area of rectangle is at h by 2 distance, with Z2 is 1.5 and Z3 is 1 meters. Right? And then we will just, as it is, calculate Z bar is equal to, what is Z bar? Z bar is A1 Z1 plus A2 Z2 plus A3 Z3 divided by total PA. Is it okay? Now, the another problem for this, where we are considering the different soil layers, which may be a triangle, which may be a cohesive or it may be a non-cohesive soils, right? Or in this, in between there is a water table, then what will be the changes in the equation? Suppose now in this case, suppose I will just consider the different place at which there is a water table. Or I just consider this soil is a clay and this soil is sand. Now if this soil is the sand and the water table is existing somewhere, now I just consider this is H1, then this is H2, right? This is pure clay and this is the pure sand. And in between this, there is a water table existing. So suppose there is a water table in this. So in that case, we will just consider this is the soil at which the diagram is a negative positive diagram. What is ZC? ZC is equal to 2C upon gamma into tan of alpha. Right? Then in the another diagram, the soil is a sandy soil. This diagram for the sandy soil is a triangular distribution because the sandy soils cannot stand unsupported for a small time. When we are making excavation into the soil, we have to provide an immediate support for the sandy soil because it is an unstable soil, right? So in this case, again the pressure distribution diagram is a triangular distribution diagram where we have to consider this is the surcharge. Now this is the bottom soil layer. Therefore, the sulfate of the soil of first layer will be acting at the top of the second layer, and there the intensity is Q. Here this is Q, which is equal to gamma into H1. Gamma 1 into H1. So again, in the second layer, this distribution diagram is due to the surcharge of intensity Q into Ka2. Then further, there the soil is in a submerged condition, gamma submerged, that is gamma saturated minus gamma W. So here these things we have to take into consideration, and the distribution diagram is positive, and this is Ka into gamma submerged into H. K into gamma into submerged into H, and again there is a water table or the water pressure, and the intensity is gamma W into H. Gamma W into H2. So in this case now, again we have to consider the three diagrams. First is the diagram for the positive distribution. This is 1, then this is 2, and this is 3. So these three diagrams we have to take into consideration. Then where the CG of this diagram, total diagram will be at, it is A1. This is at Z1 distance from the bottom, and Z1 is equal to H2 plus this distance by 3. Right? So in this case, how do we get the value of Z1? Z1 is H2 plus H1 minus ZC by 3. Right? Then what is Z2? Z2 is the rectangular distribution diagram where the CG of the rectangle is at the H by 2 distance. So it will be H2 by 2 and Z3 is H2 by 3. Right? Then how will get the PA value? PA is area of one diagram, area of second diagram and area of the third diagram. So by this way, whatever things are extra coming into the problem that we have to consider in this numerical. Many times or sometimes the numericals combines both the sandy and clay soil, so that you have to consider independently, right? But when we are considering the bottom one, we are taking the combined area of both the diagram when there is a clay soil, right? So this is the thing. Many times the numerical may ask, we calculate the active earth pressure before and after the formation plan, or before and after the formation of a tension cracks. So here we will consider the diagram in a clay soil. Suppose we will consider this is H, and this type of problems may be tricky. It may be asked many times. Before the formation of the tension crack, after the formation of the tension crack, you calculate the earth pressure. In that case, a small changes you have to do it. So here we will just consider the soil is a clay soil. The soil is clay of property C, phi, gamma. In such cases, you have to find out the value of Ka and alpha. Right? So here these diagram will be taken into consideration. This is negative, this is positive. Now, these diagram we have considered after the formation of the crack. After the formation of the crack. So here, what is this intensity? It will be minus 2c cot of alpha. It is gamma into h cot square alpha minus 2c cot of alpha. Right? In this case, how this ZC is calculated? ZC is equal to 4c upon gamma into tan of alpha. So this is after the formation of crack. So after the formation of the cracks, we are taking into consideration only positive diagram. So in this case, this is only positive diagram is taken in consideration. Okay, only positive diagram we are taking into consideration when it is asked after the formation of the crack. But if the cracks are not formed, means these are the crack formation, cracks are formed, the soil is unsupported. Cracks form होने के बाद में ये soil unsupported हो गया और minus 2c cot alpha आ गया. But if suppose before the formation of crack, cracks are never formed, in that case we have to consider both negative and positive diagram. Okay? So here only positive diagram is taken into consideration when the cracks are formed. अभी before the formation of crack, before the formation of tension cracks, only both negative and positive diagrams with net pressure we have to take into consideration. So in this case, this will be negative and positive. Both the diagrams are taken into consideration. So whatever is the negative, minus 2c cot alpha, and here it will be plus. So we will calculate the area of the positive, area of the negative. So here net pressure is equal to area of positive diagram minus area of negative diagram. Means here we are considering both the areas. ये भी लेना है, ये भी लेना है. Means here there is a negative pressure, or here there is a complete negative pressure, and here the negative pressure yet to act. Means there is a small net pressure is acting, and always remember that this net pressure is less as compared to the positive pressure. Means once the cracks are getting formed, the pressure will be more. Right? So by this way, we will just have a look of it. We will just take a look of it. Now always remember that in the sandy soil, the pressure is acting from the top to the bottom, maximum at the top and minimum at the top and maximum at the bottom. So we will just have a look of it once. Once water there is a sand, and here there is a clay or C5 soil. Okay, the pressure is immediate support is required. It can stand unsupported up to certain depth, and that depth is ZC. Means here we have to provide an immediate support when we make the excavation into such soils. Therefore, the pressure is acting from the top itself. The pressure is acting from the top itself. It will be zero at the top and increases with the depth. With depth, right? And then here zero at the top, maximum at the bottom, right? Then what is PA? PA is area of triangle, right? Area, the whole area is positive. Now in this case, it cannot, it can be stand unsupported up to a certain depth, and that depth is called as HC. Here, the distribution diagram is like this. What is the intensity at the bottom? It will be Ka into gamma into H. Right? This Ka into gamma into H, it will be minus 2C cot of alpha upon gamma into H cot square alpha minus 2C cot of alpha. This depth is ZC and HC is equal to 2 times 6. Right? So this is the major basic difference between the sandy and clay soil. Here the area of positive distribution diagram only we will take into consideration to get the value of P. Right? Here we will consider the whole area to determine the value of P. Now always remember that when there is an entry of the water table, this becomes gamma submerged. And plus, यहाँ पर if soil is submerged, in that case, instead of gamma, the gamma submerged is taken into consideration, and another pressure, that is the water pressure, is taken into consideration. Water pressure, that will be gamma W into H. Here, if there is an entry of the water table, so that is taken into consideration from the top itself, and this is gamma W into H. So this has to be additionally added into the, when there is a water table, यहाँ पर जहाँ water table आएगा तो you have to first consider the gamma into h, cot square alpha minus 2c cot alpha. This gamma is becomes gamma submerged. This gamma is becomes gamma submerged, and in addition to that, the water pressure will be at throughout to the depth, right? There will not be any negative positive. The pressure will be at throughout, and that intensity is gamma w into h, where you have to combine the diagram. When you will calculate in the total distribution, then you have to combine these two diagrams and then calculate the earth pressure. Then whatever area you are taking into consideration, below that h by 3 distance, the center CG of the triangle will be at. If suppose this much area, then it will be at the h by 3 distance from the area which we are taken into consideration for the diagram. I think there will not be any doubt in this. So with this, our second unit, that is the earth pressure, is over. In the next class, we will discuss the pile foundation, right?